This is how we define a limit in symbolic terms. Okay, so what does this mean? This means that the limit of a function f as x approaches to a equals L. Okay, so suppose we are given any function. If we draw the graphical representation of this, suppose this is a function, this is a point a, we are asked to find the limit at, then in this sense we are approaching to this point a with respect to the variable x, and then we are finding the value of this function at a. So while approaching to x tends to a for this function fx, we are getting the limit as L. Okay, so that means this value of the function fx over here, this is L. All right. So in general, while we speak this as in rough language, that this says that the value fx approaches L as we approaches a with respect to the variable x on which this function is defined. Okay. In another words, the value of fx tends or get closer to the number L as x gets closer and closer to a number a. This is the graphical this is the symbolic representation of limit of a function, where we say that fx tends to L as x tends to a. In order to see it graphically, you can see over here that this function, suppose this blue line represents a function, then at x equal to a we are having a function value as L, right? But in another figure you can see that the function value at L is not equal to L, it is other than that, something else. All right, in this case also we won't say that this particular value, say m, it is m, this is not the limit of this function, this is just the value of this function fa at a. Okay, f at fa the function has the value m but not limit equal to m. Okay, this you need to understand, because while we are approaching to a from this side or from this side, okay, we are getting this limit as L only. All right, this is not m, this is only L what we will get. So it's
Please
not
again,
about
sir.
the, hello.
Please again, sir.
Okay, yeah. So I'm saying, suppose a function which in figure B you can see is having a value m at a. Okay, that means fa is equal to m we have right now. Okay,
Please,
but we are,
can you be just using the cursor to, sir,
sorry,
using the cursor to, you are, you know the particular one you are explaining to us, sir, please.
I'm not getting you. You are not properly audible.
Hello,
Please ask
sir.
once again. Yeah.
Sir, you mean the
Uh,
soft copy?
okay, yeah, I'll be sharing all those things. Don't worry about it. Okay. If you are having any problem right now, if you are not understanding, then let me know, I will explain it. But with respect to sharing all the contents regarding this syllabus, I will be sharing it after this class. Okay.
Okay, sir.
Yeah. So did you guys understand what I mean to say? All I mean to say over here is, if a function value is something else at a point, but approaching to that point we are getting some another point like L over here, then the limit of this function is L, not M. Okay, this is the basic difference. So we are saying that while we are approaching to a point where we want to calculate the limit, in at that point, at nearest to that point, we should have that point value. Okay, some value we should approach, and that would be called limit of the function. Okay, and that limit of the function should be equal either we approach from any of the side, like from left of the that point, or from right of that point. Okay, so suppose we have this example. Okay, you can see that x minus 1 by x square minus 1, while x tends to 0, we need to find the limit. If you substitute directly the value of x equal to 1 in this function, then what will you get? 0 by 0, right? This is undeterminate form, right? But if we solve this more, means algebraically we simplify this, then we can write this as 1 by x plus 1. Can you guys see how we are writing it as 1 by x plus 1? Because x square minus 1 can be written as x plus 1 into x minus 1, right? I hope you all guys know this. Yeah, so x minus 1 will get cancelled out, and then we are left only with 1 by x plus 1. That's how this simplifying this algebraic equation, we get 1 by x plus 1. Now we can substitute x is equal to 1 in this function, right? After substituting this, we get our value as 0.5. Now this 0.5 value, either you approach from left of the 1 to 1, x equal to 1, or from right side, you will always get this point. Okay, so so in example 1 I'm sorry, yeah, if we have something like this function, okay, the function value at x is equal to 1 is given as 2, but at other places apart from x equal to 1 we are having this function. So you can see that the function g has value 2 at x equal to 1, but while approaching from any side of this graph of the function, like we are approaching from left of the value 1 and from right of the value 1, we are approaching to 0.5 only. Okay, but in another picture you see here this is the value of gx function, but here this is not the value, we are getting the limit only as 0.5. okay, this is what we talked little earlier in this earlier slides, right? Now for example,
Sir, sorry sir, can you go to the previous slide please?
yeah,
I didn't get what you said here.
okay, like we explained that the function value at that point is not the limit. The limit is the nearest value when we are approaching to the point. So here we are approaching to 0.5 from both side of the value x equal to 1, right? So here our limit is 0.5 only, not 2. Okay, this is the not the limit, only 0.5 is the limit. Okay,
No sir, I still didn't get you. So on the other side it's 1, not 0.5.
which side is 1?
Figure 4, you said both sides.
This is x, this is x, real x is x, on which the function is defined something like this. So this denotes your variable x. Okay, we want to find the limit when x tends to this x. Okay, so x tends to this x, while x is tending to this 1, then we are getting the function value as 0.5. look over here. Okay, if from any side we approach to this 1, we will get our value as 0.5. it's just
Okay,
like in this example we have shown you how to get the limit, right? So this is how you get 0.5 only. So suppose for next example we have function something like this, right? Now if one wants we wants to calculate the limit while t tends to 0, right? If you want to substitute some value which are going closer to 0, in that sense we can see that after placing t equal to 0 1.0 or 1 we say, then we are getting some value as this. Okay, more closely if we are going more closer to 0, say 0.5, then we are getting this value. More closer to 0 like 0.1, then we are getting this value. More closer 0.5, this value. Again we can see that this trend gives us an idea like our limit is going to be something around 0.166, something like that, right? We can guess from here, but in reality it is not like that. Okay, if you substitute the value t equal to 0 in this function, then our function looks like something like some value by 0 by 0 form, right? It is again coming as an indeterminate form which cannot be determined, right? So if we see graphically, right, if we see graphically how this is working, then we can see that while we calculate this function value or graphically represent this value from -5 to 5, this is -5 and this is 5, so it looks something like this. Okay, from -0.1 to 0.1, it looks something like this, and the function value is near around 1 point something, 1.66 something. Okay, sorry, 0.166 something. Okay, but if we look more closely into this, while see how small our interval is now. It is -10 to the power -6 and 10 to the power 6 -6, sorry. Okay, so in this very short interval we see that the function is changing drastically. Okay, this is going up and down regularly, and we cannot find a particular point, that which point is the nearest to our limit point, right? So more closely if we go into this, we see that the function is changing drastically, and it has some periodic kind of representation. So what we mean to say, while we are tending to that point where we need to find the limit, it is not necessary that you will always get a limit point. You might get various type of point, getting as much closer to that point, so that you cannot determine which one we should fix as a limit. So in that case we say that the limit of this function does not exist. Okay, so there exists many functions where at one point we cannot determine the limit, and we can say that limit of that function does not exist, right? So for example, if we look at this function sin x by x, right? So what you can guess from this function, that what would be the limit? Anyone can guess? If we substitute 0 in this, again we are getting 0 by 0, that is again a indeterminate form. Okay, now we want to go closer to x equal to 0, either from starting from -1, -0.5, -0.005, and so on. Okay, so we should reach up to a point which should tell us that this is the limit of this given function sin x by x. All right, so while doing so, if we are going to calculate this limit either from any side of this interval x, from left hand side or right hand side, so we will see that our limit is approaching to x is equal to 1, which is true. Okay, similarly over here, so as we tend to 0 for this function sin pi by x, then again this is giving us a indeterminate form kind of, but the limit on this you see over here we are approaching to 0, right? We started from 1, we went up to 1 by 3, then 0 0.1, 0 0.001. again we are seeing that the function value which we are getting is always equal to 0, but this limit, okay, this limit is not 0. Okay, how we'll see in this plot. You see, while we are tending to 0, x is equal to 0 from any other side, okay, we started from 1, right? Suppose we started from 1, so up to here we are getting some value which are tending to while we are getting much closer to 1, we see that how drastically this periodic function is oscillating, right? So again we cannot determine a particular point value of this function, so we say over here also that limit of this function does not exist. However, over here while we are manually going leading to point 0 from either side of the x variable, we are saying that we are getting some function value as 0 0 0, but it is not 0, it is drastically changing. All right, so there are some what we have seen in previous examples, that there exist some functions where which does not have a limit at a given point. In that sequence we have one more example of Heaviside function. We call this function as Heaviside function, which says that when t is less than 0, then we have function value as 0, and if t has a value greater than or equal to 0, then we have a function value as 1. Okay, so in this case, as t approaches to 0 from the left side, you see we have something like this. Okay, so let me change the color over here. Okay, so this is your function value. Okay, so while t is less than 0, we have x is our function value as 0, ht is 0, this is our ht. Okay, now while t is greater than or equal to 0, so we have function value which looks something like this. Okay, which is having 1 at t equal to 0 and greater than equal to 0. Okay, now in this case, while we approach from left hand side to point x is t is equal to 0, right? While we are approaching from the left hand side, what function value we are getting? We are getting the limit as 0, right? What is the limit we are getting? We are getting 0. But while we approach from the right hand side, we see the function value is attaining 1. All right, so at a point we cannot have more than one limit, right? That's why over here, since we are getting two limit points, so the function does not have a limit at t equal to 0. Is that clear, class?
Yes, sir.
Yeah, so you can see over here, right? This is the graphical representation of this Heaviside function. While we approach from this side, we are getting 0, but we are approaching from the right hand side, we are getting the function value as 1. Okay, now what is this is what we have learned in our previous slide. This is called one-sided limit. Okay, one-sided means either you are approaching from left hand side or right hand side of the variable, x variable on which the function depends. Okay, so yeah, this we already talked about, that if you are approaching from left hand side, this is how you represent that you are approaching from left hand side. You see 0 negative is there, that means you are approaching from left of the that function point value t equal to 0, and if t plus is there, that means you are approaching to the point t equal to 0 from right hand side. All right. So what does our definition say? We say that x limit x tends to a negative for fx equal to L. The limit is L if the left hand limit fx that approaches to a has the value equal to L. Okay. So that means if we go sufficiently close to point A, then we should get the function value as L only. All right. So what we have seen in definition 1, that is different, because in definition 1 we saw only that x tends to a. We were not particularly talking about a negative or a positive, and this is what our one-sided limit is telling. Okay. So in order to find a limit of any given function at a point, it is necessary for us that both sided limit, either left hand side or right hand side, they should coincide. We should get the same value. Otherwise we will say that the limit of this function does not exist. All right.
No.
Sorry, sir, I didn't get that.
Sorry, sir. Repeat, please.
Okay, I'll repeat once again. We will say that a function, yeah. So we will say that a function fx. I'm sorry, man, you are interrupting, and please ask. Please ask. Hello. Yeah, please ask. Okay, I think I should carry on, right? So I am saying that a function fx has limit L only if both sided limit, that is when we are tending from left hand side to that point or from right hand side to that point, if those values are equal. Okay, like here, if we are given any function and we want to calculate the limit at point A, then if we are approaching from left hand side and we denote it something like this, limit x tends to a negative, then we are getting L. Okay. Similarly, if we approach from right hand side and we get the same function value as L, then we will say that function has limit x is equal to L. So symbolically, if we write, this would be a precise definition. We will say that a function fx has limit L as x tends to a if and only if the left hand limit and the right hand limit, these two are equal. All right.
Understood, sir. All right. Thank you.
Sir, what
Yeah.
about the negative A and positive A? Doesn't it make a difference?
It does make a difference. That's why we are calculating negative A and positive A. It doesn't mean like negative A or positive A. It just means A negative means that we are approaching from left of that variable to A. Okay. It means that like suppose you have some particular positive number epsilon, let us say. Okay. Are you getting me?
Yes, sir.
Let us say that we have some positive number epsilon greater than 0. Okay. Then if we are saying A negative, then what does it mean? That we are something less than A, that is A minus epsilon. Okay, we are calculating the limit at this, and while epsilon tends to 0 now, okay, so we will indirectly approach to x is that point A, right? Am I correct? If I am asking you to subtract some positive number from a given number, that means you are less than that number, right? And if I am saying that that subtracting number which I have provided you tends let us take this value as 0, then indirectly we are approaching to our original number, right? That's what we mean over here. So A negative means that you are something less than A. All right. and A positive means that you are something greater than A. That's why we are saying that if we are less than A, then that is left hand limit, and if we are greater than A, then we are right than the that point value x equal to A. All right. For example, if we consider this, okay, this function 2x by x minus 3. All right, so if we substitute directly x equal to 3, we will see that this is going to be a infinity kind of value. Okay, we cannot determine this value also, we call it as infinity. Okay, something by 0 is always infinity, but which infinity, either it is negative or positive in direction. Then if we plot this graph, we see that graphical representation of the function is something like this, where if we approach from the left hand side to x equal to 3, that means this limit x tends to 3 negative, this gives us minus infinity, right? You can see that this function value is going deep down, okay, as we tends to x from this side. Okay, so that means it is attaining a value of minus infinity. All right, but if we approach from right hand side, we see that the function value goes to infinity, right? That is positive infinity. So again we have different limits if we approach from different side of the graph, or from two different side of the function point value x equal to 3. Okay, so we will say that here also the function limit does not exist. Okay, so these are this is just a simple question. I want you guys to answer me. So first question, we see that we need to find the limit while we are tending to x equal to 2 from left side of the graph, because 2 negative denotes that we are approaching from left side. So please tell me what would be the answer. Someone? Yes guys. Yeah guys,
So I
please
think you
answer.
still need to make a recap.
Sir.
Yeah, I'm
I
sorry,
think you still need to make a recap.
I need to,
Repeat.
sorry guys, I did not hear you.
Sir, may you repeat the question?
So your voice is too low.
I think you
Okay, so I am asking what would be the function value while we are approaching to x equal to 2. Okay, our function a x, sorry, yeah, please tell. While we are approaching to x equal to 2 from left hand side, then what is our function value? Yes class.
So how are we supposed to use this graph for this question? Can you solve one of these to just
Yeah,
make it clear?
I'll definitely do it. I'll definitely do it. I want you guys to be active in class. That's why I am asking you questions. Okay, if you want answer, then I'll go to answer you. Okay, so you see over here what our function is showing us that if we approach from left hand side, okay, if we are approaching from left hand side, then we are following this graph and we come to this point. Okay, and this value gives us gx is equal to 3. Okay, so answer for our first problem, that if you are tending to x equal to 2 from the left hand side, then we are getting the function value as 3. All right, now if we are tending to this point x equal to 2, okay, from right hand side now, okay, So from right hand side, if we tend to this function, we'll follow this graph. Okay, so after following this, we reach up to point 1. All right. So the function value, while we approach from right hand side to this point x equal to 2, we are getting it as 1. All right. But now they are asking what is the limit when x tends to 2. Okay, they are not saying that either from left hand side or from right hand side. So you see, from left hand side we got 3, right, from right hand side we got 1. But if they are asking us that what is the limit when x tends to 2, then we have two limits, and two cannot be, we cannot have different limits at the same point. All right, so we say that the limit does not exist. Okay, is this clear, class? Anyone is having any query?
Sir, how can you be so sure, like if you're going from 2, like for A it will be, the answer will be 3, and for B if you're going down you'll just reach to 1, not 0.5 or something?
Because as much closer as you are going to 1 from either side, you do not see any discontinuity. Okay, even you are reaching up to nearest closest value as much as you can think of, we will get this function value as equal to 1. All right.
So is it the next value? For example, if we could come from like 3, for example, for B, if it could be x is 3 plus 3 positive sign up. So could we say the answer is 2 over there?
For 3, if you calculate, so
Not
this
3,
is some
for Roman B. For B, if you say the value for x is 3.
Yeah.
So what would be our
You want
answer?
to calculate at x equal to 3, or okay?
Yes.
That's it. Okay.
Yes.
So if you want to calculate at x equal to 3, let me just clear it. Okay. Can we clear this? Yeah, I think. Okay. If you want to calculate the limit at this point x equal to 3, then in that case, if we approach from left hand limit, okay, so we will follow this graph over here up to here. Okay, and this value is something like 1.5. okay, let us assume that this is something like 1.5. Now we approach from either this
So
side
you can
also,
clear
we
from
will
there.
limit at, yeah.
Sorry, sir. You, please go to where you are choosing the colors. There is an eraser over there.
Okay, yeah, I got it.
Yeah.
So yeah, okay, now you want to calculate the limit at x equal to 3. All right,
Yes.
so we will follow from left hand side to point x equal to 3. So we are getting some value over here, that is, let us say 1.5. all right.
Yeah.
Now if we go from right hand side also, we are approaching to the same point. Okay,
Yeah.
are you seeing that? Yeah. So
Yes.
I mean, if you go as much closer to that point, you will get some point. Okay, in fact, if you get same point from if you reach to the same point, then only we will say that limit exists, and that is the limit value. Okay, if we are approaching to two different points from going from either left hand side or right hand side, then we will say that function limit does not exist over there. Okay, yeah. Now
Understood, sir. Thank you.
yeah, if you see question D, they are asking what is the function value when you are approaching from the left hand side to x equal to 5. So tell me what you guys see over here. Same thing what we have discussed right
Sir,
now with
please
respect
erase
to x equal to
everything.
3.
The answer be 1.5, sir.
Yes.
The answer be 1.5.
1.5, sir.
This is something like 2. Not sure, but This is something like
Oh,
2.
sorry, 2, yeah, 2, sir, not 1.5, 2.
Okay, yeah, you see it is approaching to 2, something like 2, but whatever it is, we are approaching to the same point from left hand side and right hand side. So the solution of problem E is also same. Okay, that is, let us say 2. Okay, but what about F when x tends to
Does not
5? What is the
exist.
function value? No,
Does not exist.
no, it is existing,
Nine.
because from either
And
side you
sir,
approach, you are getting function value as 2 only. All right,
yeah.
yeah, so the function limit exists, and that is 2. However, the function value at x equal to 2 is not sorry, x equal to 5 is not 2, it is something else. You see over here?
1.5.
Yeah, something like that, you say something else, but still our limit is x gx is equal to 2. All right, is that clear, class? You should not get confused with respect to the function value
Yes, sir.
at the point and function
Sir,
limit
please
at
could you
that
repeat
point.
about x is 5?
Yeah, I am again repeating. The function value at x is equal to 5 is something like 1 point something. Okay,
1.5.
but we are getting limit as x is gx is equal to 2 if we either approach from left side or right side, doesn't matter, our limit is 2 only. Okay, all right, class?
So that means to use the graph to find our answer. Use the arrows.
Okay,
Use the line.
so I think we have crossed the limit of our class time. So if you guys are having any doubt, please ask, otherwise I'll take your